Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover point 8.4.2 about plane. Okay, so 8.4.2.1 about equation of planes. So there are three criteria for us to find the equation of a plane. Okay, the first criteria, firstly, a plane in space has normal vector. Okay, n equal to ai plus bj plus ck, and that it passes through a fixed point of point A. Okay, and then criteria number two, a plane passes through three non-collinear point in the plane. And then criteria number three is a plane parallel to two given vector in different direction and passes through a point. Okay, first let's look at criteria number one. Okay, criteria number one specifically mention that a plane in space has normal vector. Okay, so criteria number one, let's say we have a plane right here. Okay, and then this plane has a normal vector that is perpendicular to the surface of the plane. Okay, so this normal vector represented with a vector n. Okay, so this n is a vector, okay, where the vector is in the direction of 90 degree coming out from the surface of the plane, okay, and that it passes through a fixed point A. Okay, then which means fixed point A is actually any point on the surface of the plane. Okay, so A is a fixed point of point A on the surface of the plane. So the equation to represent the vector equation of this plane is r dot n equal to a dot n. Okay, so later on I will explain more detail about this. Okay, now let's look at criteria number two. Okay, criteria number two is a plane passes through three non-collinear point in the plane. Alright, so let's say we have a plane. So on the surface of this plane, we have three collinear points. We can label it as a point A, point B, and also point C. Okay, so in order to create an equation of a plane, we need a vector that is perpendicular to the surface of the plane. So by finding the vector of A to C, and then A to B, and doing a cross product between A, B cross A, C, then we will have a vector n that is coming out from the point of A. So this vector n is perpendicular to the surface of the plane. Okay, so that is about criteria number two. Okay, then criteria number three, a plane parallel to two given vector in different direction and passes through a point. Means we have a plane and then we have two different vectors that is moving on the surface of the plane. Okay, these are the vector on the surface of the plane. Let's say this is a vector A and this is vector B. So what we need a vector that is perpendicular to the surface of the plane, and by doing A cross B, okay, then we will have a vector n that is perpendicular to the surface of the plane. Okay, so this is literally a summary of what is meant by the criteria number one, criteria number two, and also criteria number three. Okay, now let's look at a little bit more deeper into criteria number one. Okay, criteria number one tells us that we are given a plane and also the normal vector that is normal to the surface of the plane, 90 degree to the surface of the plane. And The plane also has a fixed point of point A, and then the plane also has another point which is called as point R. Okay, the point R is actually quite similar to the point of R that we already see in the straight line equation. Okay, which means R is any point on the plane. Okay, so means R is movable. R is any point on the plane. It could be anywhere as long as it lies on the surface of the plane. Okay, so we know that since both point A and R lies on the surface of the plane, okay, both of point A and R lies on the surface of the plane, means A R, okay, vector A to point vector A R dot product dot with vector N that is perpendicular, okay, then it will be equal to 0 because vector AR and vector N is perpendicular to each other. Vector N is perpendicular to the surface and vector AR is lies on the surface of the plane. So then it will be equal to 0 when we do the dot product in between them. So AR will be equal to OR minus OA dot with N. So it will be equal to 0. Okay, then we can say that OR is equal to vector R minus vector A dot N equal to 0. Then R dot N minus A dot N will be equal to 0. So R dot N is equal to A dot N. Okay, so this is what we call as a vector equation for a plane. Okay, so this is the vector equation for a plane. Okay, so now remember, okay, criteria number 1, it gives us the value of vector n that is perpendicular to the surface of the plane and also the fixed point of point A given. So this must be given and this one must also be given. Okay, now let's look at example 8.35. Okay. Okay, now we want to find the equation of the plane with normal vector. Okay, means we have a plane and with a given vector of n, normal vector, that is I plus 2j plus 3k, and containing the point -1, 2, and 4. So this point -1, 2, and 4 is the point that lies on the surface on the plane. -1, 2, and 4. So we want to create the equation of the plane. Okay, so equation of the plane starts with r dot n equal to a dot n. So r is unknown, so it could be anywhere. So it stays as an r dot n is the vector that is perpendicular to the surface of the plane. That is I 2j plus 3k equal to, okay, and then the vector of A. So this is the point of A, means from the origin, the position vector, -I plus 2j and plus 4k, and multiply dot product with vector n, I plus 2j plus 3k. So R dot, okay, you have to do the dot product for this side. So it will be equal to 15. So this is the vector equation of a plane. So remember that it starts from the r dot n equal to a dot n. Okay, so there is also another form of equation that is called as the Cartesian form or Cartesian equation for a plane. Means you have to expand first. The vector r is the xi, yj plus zk dot with 2j plus 3k equal to 15. Okay, and then we have to do the dot product. So x plus 2y plus 3z equal to 15. Okay, then the Cartesian equation is x plus 2y plus 3z minus 15 equal to 0. So this is what we call as the Cartesian equation. Alright, then for criteria number 2, okay, we go through with example 8.36. Okay, so example 8.36, okay, mention find the equation of the plane through point A, B, and C. Okay, means these 3 points of A, B, and point C, okay, must lie on a surface of a plane. So let's say this is the plane. Okay, so in order to create the equation for that plane, we must find the equation that is perpendicular to the surface. So equation that is perpendicular to the surface of the plane can be found by finding the vector A to B, okay, then vector A to point C, A to C. Alright, then we have A to B is equal to, okay, vector A to vector B is equal to 4i and then minus j and then plus k, and then vector A to vector C will be equal to vector A to vector C is 2i minus 2j and plus 3k. Alright, so the line that is perpendicular, okay, the vector that is perpendicular to the surface of the plane must be equal to the AC cross product with AB. So we have I, J, K, okay, 2, -2, 3, and 4, -1, and K, sorry, and 1. Okay, so it is equal to -2 plus 3i minus 2 minus 12 and then plus -2 plus 8k. Alright, so it will be equal to I and then plus 10j and then plus 6k. Alright, so this is the equation that is perpendicular to the surface of the plane. And then the equation of the vector will be r dot n equal to a dot n. So r dot n, which is the I, plus 10j plus 6k equal to a. Okay, a is the position vector of point A, which is the -I plus 2j, okay, k is 0, and then n is I plus j plus 6k. So r dot k equal to -1 plus with 20. So r dot I plus 10j equal to 19. So that is the vector equation for the plane based on the criteria number 2. Okay, now let's look at criteria number 3 by solving the example 8.37. Find the equation of a plane passing through point A and parallel to the vectors B and C. Okay, means the plane is parallel to vector B and C, means that parallel vector B actually lies on the surface of the plane. Okay, also the same thing happened for vector C. Okay, so that is what meant by the plane parallel to the vector. Okay, vector B and vector C lies on the surface of the plane, and the plane also passing through point A, which is at 3, -2 and -1. Okay, so firstly we have to find the vector that is normal to the surface of the plane. Okay, by taking B cross C. Okay, I, J, K. K is 1, -2 and 4. Okay, so the cross product between vector B and vector C is equal to 2i plus 17j plus 8k. Right, so this is the equation for vector that is perpendicular to the surface of the plane, n equal to vector n. Alright, so since we already have a point that is fixed on the surface of the plane, so equation of the plane is r dot n equal to a dot n. So r dot n equal to a is position vector of coordinate a, 3i minus k. Okay, dot product with vector n, 2i, 17j plus 8k. Alright, then we have r dot n, r dot with vector n is 2i, 17j plus 8k, that is equal to -36. So this is the vector equation. In Cartesian equation, so it will be xi, yj, zk, 2i, 17j, 8k equal to -36. So 2x plus 17y plus 8z plus 36 equal to 0. So this is the Cartesian equation. There is no parametric equation for plane. Okay, only vector equation and Cartesian equation. Alright, we continue to practice with example 8.38. Show that the line L whose vector equation is R. Okay, this is a line is parallel to the plane of pi whose vector equation is r dot n equal to 5. It means on the plane, okay, we have a plane right here. So this plane has a vector that is normal to the surface of the plane. That is Rn equal to I plus 5j plus k. And then we have a line. We didn't know in which direction does it's pointing. Okay, so this line has a direction vector that is equal to I minus j plus 4k. Okay, we have to show that the line L and the plane pi is actually parallel to each other. Alright, okay, means this line L, when it's parallel to the plane, means the line L actually lies on the surface of the plane pi. Okay, so when L is parallel to the surface of the plane, so the line L must be perpendicular to the vector normal to the surface of the plane. It means N must be perpendicular to the line L. Okay, means if you take N, you dot product with a vector V, okay, then it will be equal to 0 because cosine 90 degree will be equal to 0. So you have to just prove by doing dot product between vector N and vector V, then you will obtain 0. So you already shown that vector N, you already shown that line L is actually parallel to the surface of the plane. Okay, so if you take I plus 5j plus k dot with v I minus j plus 4k, so equal to, sorry, we didn't know what it will be yet. So we have 1 minus 5 and then plus 4. So it is equal to 0. So equal to 0 means pi and line L are parallel. Okay. Alright. Next example is example 8.39. Find the vector equation of line passing through point 312. It means we have a line that is passing through point, let's say the point is right here, 3, 1 and 2, and perpendicular to the plane. So means this line greater than, it is perpendicular to a plane. Okay, so we have a plane right here. So this line is perpendicular to the surface of the plane. And given that the equation of the plane is r dot 2I minus j plus k equal to 4. Okay, so this is the vector n that is perpendicular to the surface of the plane. So means we have vector n that is coming out from the surface of the plane. So 2I minus j plus k. So at the same time, this vector n must also be parallel to the line that is going through point 312. So R equal to A plus PV. So R, A, we can choose this point of 312, 3I plus J plus 2K plus T, and then V is the direction vector of the line that is parallel to the vector n. So we can just take vector n to I minus j plus k. So that is the equation, vector equation for the line. Alright. Okay, next we have to find the point of intersection of this line and the plane. Okay, the point of intersection. Okay, so we have the equation of the plane right here. and this is the equation of the line. So to find the point of intersection, you have to substitute the r with the r on the equation of the plane. So that will be 3i plus j plus 2k plus t 2i minus j plus k, okay, dot with equation of the plane 2i minus j plus k, and then equal to 4. All right. Okay, so right here, we have to solve the one that in the square bracket first. So it will be 3 plus 2t I 1 minus t j plus 2 plus t k 2i minus j plus k equal to 4. Okay, then you do the dot product. Then you will have 6 plus 4t sorry 6 plus 4t plus negative 1 plus t plus with 2 plus t equal to 4. So you solve it to find the value of t. So t plus 7 equal to 4. So you have t that is equal to negative 1 over 2. Okay, so since we have the value of t, okay, so then we substitute the value of t into the equation of the line. So r is equal to 3i 2k plus negative 1 over 2 2i minus j plus k, right? Then you will have the value for vector r is 2i plus 3 over 2 j plus 3 over 2 k. So this is the vector r. So r is actually a position vector from origin to the point r. So we can say that the position of point r is at coordinate of 2, 3 over 2 and 3 over 2. So this is the point of intersection between the line and the plane. Okay, so if you wonder why we are looking for the position of r, okay, because if you remember, r is actually any point along the surface, along the line, okay. As I always say, r is movable, so r can be anywhere along the line, and also r is also any point on the surface of the plane. So when we substitute the r from the plane into, when we substitute the r, the equation of r, or from the straight line into the equation of the plane, we actually saying that the r from the straight line is on the same place as the r from the surface of the plane. So because r is movable, so I want to place my position of r right here, right where the line and the plane intersect with each other. Alright, so that is the explanation why we are looking for the coordinate, the position vector of vector r.